The Flexcore has a revolutionary heat exchanger design that can equally absorb heat deformation, as well as prevent air bubbles and sediment from accumulating on and around the crown sheet. Let's take a look at the design and see how Flexcore is changing the way we think about heat exchangers. 1. Air removal. Due to their lower density, all air bubbles are going to rise in water. So the Flexcore's crown sheet has been designed with a convex shape that forces any air bubbles in the water inside the heat exchanger up and away from the middle of the crown sheet. The Flexcore's unique baffle design increases the water velocity across the crown sheet, ensuring that all bubbles are swept away in the flow, even if your system is set to a low pump speed. These features prevent air bubbles from sitting on the crown sheet. Air bubbles sitting on the crown sheet will create a hotspot on that sheet. This is because the incoming heat is insulated by the bubbles and cannot be transferred to the water below, leaving only the metal to absorb the energy from the burner. 2. Sediment removal. Just as the bubbles are swept away in the high-velocity feature of the Flexcore's heat exchanger, so are any impurities in the water. This helps prevent impurities from crystallizing and forming blockages, as well as ensuring that impurities will not linger close to the crown sheet and burn up from the heat. 3. Radial expansion. Matter expands when it heats up and contracts when it cools down. This is especially noticeable in the high heat conditions of a boiler's combustion chamber. A traditional crown sheet is flat and has a linear expansion, which can create inconsistent deformation. Inconsistent deformation can form concave warps in the crown sheet for air bubbles to get trapped in. Think of your mother's cookie sheet that doesn't sit flat after baking the first batch of snickerdoodles. The convex shape of the Flexcore's crown sheet expands radially and has a consistent, equal, and predictable deformation under heat. Just like how a glass bowl doesn't shatter when you bake with it, the Flexcore's crown sheet is designed to absorb the deformation rather than trying to fight against it. 4. Even airflow distribution. The Flexcore's heat exchanger has been designed to allow flue gases to flow down each tube equally. A traditional heat exchanger's tubes can get neglected around the outside of the crown sheet, because the flue gases aren't getting dispersed and are following the path of least resistance straight down the middle. This is especially important when the boiler is in low fire. This is because the incoming flue gases will be under lower pressure. In a traditional heat exchanger, the flue gases would tend to stick even closer to the path of least resistance due to the existing static pressure in the combustion chamber. If flue gases are only passing through the tubes at the center of the heat exchanger, there will be uneven heat deformation across the crown sheet, and any uneven deformation increases the chances of creating a permanent warp. If that warp is concave, it's an easy place for air bubbles to get trapped. The trapped bubbles would then perpetuate the cycle of inconsistent heat transfer. When considering your next boiler, remember, your crown sheet is going to expand and contract. It's a simple fact of heating up and cooling down. The Flexcore's heat exchanger controls that deformation with its convex crown sheet design and even flue gas distribution. The Flexcore's heat exchanger also prevents inconsistent deformation with two methods. The convex crown sheet design forces bubbles up and out, and the high velocity zone keeps the bubbles and impurities moving.